So good morning, everyone. As Jarek mentioned, my name is Piotr Wieczorek, and I'm a lead product manager for Cloud Composer at Google. And I'm super excited to be here at Airflow Summit in Seattle. And today we'll talk about MLOps. And I'm also super happy I have a chance to co-present that session with Priyanka, who is a senior manager at Priceline. And Priyanka will share with you a very interesting use case and her story with MLOps at Priceline. But before that, I will do a short introduction. And just to set the stage, as we all know, AI is every day these days, and it's no longer a question of if, but how we implement it. And as the AI hype is absolutely real, as for 83% of companies, AI is the topmost priority. And as Gartner predicts, by next year, 80% of companies will try to implement their Gen AI use cases into production. But at the same time, there is a massive production gap because, as data suggests, up to even 80% of all AI project stalls before ever reaching production. And you may ask, like, where is the disconnect coming from and what's causing that? And as per Harvard Business Review, although all of the leaders are bought into, or most of the leaders are bought into AI, only 10% of them actually feels that their company is ready to deliver on AI projects. And what they usually cite is the bad data foundations or poor data foundations and integration challenges. And this is a challenge with MLOps, that it's not only about building the model, but it's actually about building a robust and automated system around it. And this is where orchestration becomes a hero of the story. As this production gap is a key challenge, the data teams consolidate around orchestration. And of course, Airflow being the industry leader, it also becomes a leading solution for MLOps orchestration. And the data from recent Airflow surveys speaks for themselves. As you can see, more than 30% of Airflow users already uses Airflow for MLOps. 40% want to use it in the upcoming future. And 32% would like to see better support for MLOps in the upcoming releases of Airflow. And as we work with our customers on Cloud Composer at Google, we see four most common use cases for MLOps. And starting from basics like data engineering and quality checks that are usually done by customers using BigQuery operators, data flow, data form, and data transfer service to ingest data into BigQuery. Then there is end-to-end model training that also includes features engineering, usually done on Vertex AI. But also a number of customers these days use Jupyter notebooks as first-class citizens, and they run their ML workloads directly on Jupyter notebooks using paper mill operators. Then we have more specialized GPU-centric workloads, batch inference, where customers run large amount of data through pre-trained model. And finally, the new and fastest growing one, which is Gen AI LLM ops, like, for example, building complex RAG pipelines for Vertex, for vectors embeddings or fine-tuning of the models. And then you may ask, okay, we have those use cases, but how customers usually implement that? What are the architectural patterns that we see? And there are two most common patterns that we see our customers are using. And the first one is Airflow as the orchestrator. The second one, Airflow as the engine. And as the former is probably a golden standard and the traditional use of Airflow, where Airflow acts as a control plane, intelligently managing and triggering all the underlying specialized software like Vertex AI. There is a new patent, which is less common, but is becoming more and more popular, which is using Airflow as an engine to actually run a heavy compute directly on Airflow clusters, on Airflow workers. And as we zoom in into each of them, like for the first pattern, the most common steps that are usually built into the solution within this pattern are, first of all, obviously ingestion of data into BigQuery through DTS or cloud storage. Then there is a preprocessing done using data form, data flow, or BigQuery itself. Then there is a model training with Vertex AI. Then the best performing and validated models are being pushed into Vertex AI registry. And then finally, there is an automated deployment to production for Vertex AI endpoints. And then there is the second pattern that we see, where some or most of those steps, especially compute-heavy steps, are done within Airflow itself. And when it comes about the popularity of this pattern, again, the Airflow survey data speaks for themselves. As you can see, almost 30% of Airflow users already uses Airflow workers for heavy compute. And similar amounts would like to see a better support for heavy compute directly on Airflow workers in the upcoming future. And as of today, most of those CPU-centric workloads are usually executed with celery workers, like using Python operators or Kubernetes executors. Those GPU-centric ones are usually offloaded to GPU-enabled GKE clusters using GKE operators. But this is today. But obviously, with the introduction of Airflow 3, there is this new concept of remote workers, remote executors, that actually allows you to install workers on dedicated heavy compute machines, for example, with GPUs, either on the cloud or on-prem. And that actually makes this pattern even more simplified, and potentially this pattern would evolve into those executors. And although there are obviously pros and cons of this second pattern, I think in summary, the key benefits that our customers see with this pattern is simplified implementation, reduced complexity, at the same time maintaining the security and scalability. Like with that introduction, I will hand over to Priyanka, who will give you who will share her story with the first architectural pattern that they've implemented at Priceline. Over to you, Priyanka.
Thank you, Peter. Good afternoon, everybody. So yes, we have been a very happy customer of Google Cloud Platform, and I wanted to share our journey in Priceline, how we have used Airflow through Composer to basically accelerate our product. So this is what you see is ML-powered Priceline. So we have a lot of ML models that runs at the backend to basically to this listing page, for example, for Priceline, if you could see that is like sort by recommendation. So it's like a recommendation model which is running at the back end to show this hotel listing page, look up for the place and the date. And based on our data warehouse data, we do a lot of pre-processing and the whole ML pipeline. So Airflow has been actually came as a blessing to us because the time to put all of these product features into the market was greatly accelerated. With the help of Airflow, we were able to completely create a very secured, robust, scalable, automated pipeline that helped us to kind of answer the problem of the MLOps. We were able to do our data pre-processing that uses the primary sources, which is like BigQuery, GCS, Kafka, you name it. And then we would do the linting, the testing of the code, the Dockerizing of our code, and the code would actually be doing the training of the model, and then the model would be creating the pickle files, which we would store in the GCS bucket. Then we would uploading it into the model registry of GCP and then serve at the endpoint if it is an online served model, or we would do some batch processing. Um, so this whole thing, Airflow really helped us because we were consuming it through the Composer managed service of GCP. But this is again to reiterate what Piotr was saying, the building blocks of ML. Today in Priceline, most of our data warehouse is like BigQuery is our data warehouse, but we have a lot of raw data in the cloud storage because we are using the Kafka to stream it there. And then we have also got the Cloud SQL. So we have to do a lot of pre-processing data, like feature engineering, and then comes the training part. And then we are heavily using the Vertex compute to do the uploading to the model registry and then serving it through the endpoints. Being said that, I just want to walk you through the architecture that we invested a lot of time in. We did a lot of POCs, a lot of things that we worked, and then it didn't work. And then finally, we were happy when we came up with this architecture. So obviously, our code, we were writing it and we were putting it into the GitHub for version controlling. And then the magic came when we would do use the Airflow features of the DAGs as an orchestration layer to orchestrate our pre-processing pipeline, the training pipeline, the serving pipeline, and the endpoint hosting of the models. And we would primarily do it using the composer, where the DAG deployment would push the code into the composer bucket so that we would have the Airflow to show all of those. And then the code would also be containerized and uploaded into the Google Artifact Registry. And then we would be doing the other steps and step by step, where the code would be actually using the GCS bucket as its staging place for the model to create the pickle files. We would also use a lot of data flow jobs to do our pre-processing of the data, because it's a heavy compute in the terms of lifting up of the data. So we relied on data flow to do all of the pre-processing work. And then, as you can see in the Vertex suite of it, we would have few of the jobs that would require hyperparameter tuning. We would have our own custom jobs. Sometimes we would do the fine tuning of the models, and then we would upload them into the model registry. And few of the models would require it to be served at an online, like an online based. So we have to host it across the endpoints so that the downstream API teams could actually consume it to be showed into the listing page, as I just showed you before. So they would just go there and just consume the model from the endpoint and show it on our website. And then finally, we have been using the Arise as our monitoring tool for all of these models. So this is the complete architecture that we have been using in Priceline. And with this feature, we have been able to put our ML-powered products into market in very less amount of time. So there were many prior challenges which we were able to solve with this pipeline. Initially, obviously, we are very new into this ML world as a product to be launched. So we were having the issues having the monolithic structure of the code. So every time a model is to be built, if there are other models and the use cases, we would just rebuild the whole Docker container again because it was not following the correct structure. The DAGs were not designed in the right way. We wouldn't be completely utilizing all the features of Airflow. So that was also something that we were working on. We had to do a lot of manual changes. It was not secured. We didn't have the dedicated way to use it. Now that we are on GCP, as you can see at present, we would have our dedicated service account, which will be tied up with a particular use case. So that service account would have the access to the specific resources on GCP. So if a use case needs access to the BigQuery table, that only we would render the permission to that particular table. Or to compute the vertex cost, we would just give the service account the ability to call the vertex for that particular project. So it was very much boxed. It was the IAM management and everything was taken care of. We use a lot of reusable workflows in the DAGs so that we could use the same DAGs for training, for pre-processing, and serving, but in a different mold based on the use case. We have a dedicated QA and the pre-prod environment because we spin up now the composer in a QA as well as in a pre-prod environment so that we can basically test the model end to end before we push it into the production. And also because we are in GCP, so as Piotr mentioned, that based on our use cases, sometimes we would use GPU-based machines. Sometimes we would use CPU-based machines based on the requirement and the use case, and have it deployed across different regions because so that it's highly available and it is catered to the customers as they need. What was the impact we saw with this pipeline? We could actually push so much more models and products into the production. These are just the data for the last quarter, which is like June, July, and August. We saw that it was vastly adopted across the teams when we enabled this feature in our platform, and they were able to push iterative changes in their code and products into the production. So we had a lot of use cases like sorting algorithms, listing algorithms, recommendation algorithms, which was powered by this pipeline. And you can see that ROI and the efficiency. Previously, it used to take us approximately like a quarter to build this whole end-to-end process because there was no MLOps in place. But now with that, we significantly reduced that to less than a week to push our code for the developers who are writing their code into the Jupyter notebook, into a QA environment, and then into the production environment in less than like 7 days, because now we have got proper CI/CD pipeline and proper MLOps in place. As a next step, we are actually working right now to incorporate the Airflow provider operators that it works with the Vertex, where we can do our own, like use these operators to do the hyperparameter tuning, the custom jobs, the serving of the model, and the others. Those will be the next steps. And yes, that's pretty much it.